Okay, now let us start. So, motion in a straight line we are going to start. Okay, so today we are going to discuss motion in a straight line. Motion in a straight line. Motion in a straight line. So, what are we going to discuss in this chapter? What are the important topics? So, first is that we have to understand the very basic concept about important terms, right? So, some of the important terms which we need to discuss is about position, position, distance, distance, displacement, displacement, speed, velocity, acceleration, acceleration, and jerk. You can keep your this audio mute. Okay, so whenever you need to tell anything, you can unmute and tell. Okay, right. Okay, so these are the important topics. First, we will discuss about these topics. After that, we can discuss next about the graphical concepts. Graphical concept. Graphical concept. Then comes under motion under gravity. Motion under gravity. After that, the last topic is relative motion. Relative motion. Okay, so these are the 10 topics of this chapter. Motion in a straight line or motion in one dimension, 1D motion, one dimension motion. Okay, so let us start these topics one by one. So first we will discuss about position and then we'll go next. So first thing we need to note here that what is motion. You already have some idea about motion. So when do we say that the object is having motion? So the object is having motion when it is moving, right? If it is moving, if it is not moving, then it does not have any motion. So when can we say the object is moving? So when the object's position is changing with respect to time, that is what is motion. So motion means motion when the position of an object is changing with respect to time with respect to time, then the object is said to be in motion. If the position of the object is changing, for example, let us understand this. This is the definition. When the position of an object changing, it is changing with respect to time. Okay. So now the first the question is, what is position? We have to understand it fully. Okay, because you are preparing for NEET, and nowadays in NEET the questions are tough questions because they are giving lot of conceptual questions. It is not just formula based questions. Okay, so we need to understand deeply the concept. First of all, this statement says that when the position of an object is changing with respect. So first of all, position means what is meant by position. And second thing is that according to whom it is changing. For example, suppose if I see a car moving, okay, if I see a car moving, then I will say that the position of the car is changing with respect to me. It is changing. Suppose car is moving, so I will say car was here, then car was there, then car has gone. So that means I can see that car is moving, so I will say the car is in motion. But suppose if there is a man who is sitting inside the car, he will not see car moving, right? He will not see car moving. He will see outside things moving. So it is a very important to understand who is the observer. So all this measurement has to be done with respect to an observer, with respect to an observer. So let's understand. Suppose that there is an observer, a person. This person is standing here and he sees a car. He sees a car, and this car is some distance from him. Let us say some distance this car is. Let us write this as x. Here x represent position. X is the position of this car. Okay. So if this car is moving, then x will be changing with respect to time and with respect to this observer. So if x is not changing, then it is at rest, it is not moving. Okay, so this is first you have to understand. If x is constant, then you can say no motion, or you can say rest. And if x is not constant, then motion. Are you understanding this? Yes. Okay. So anytime you have doubt, you can ask me question. Okay. Anytime if you have any doubt. So first of all, let us understand this again. So if this car is moving with respect to this observer, note that this observer is measuring this position. How much it is? 2 meter, 3 meter, 5 meter from him. He is measuring that. Okay. So he can definitely measure the distance, and if this position is changing, then he can say that it is it is under motion. If the distance or position is not changing, see here position means what? Now here very good question can be there. Suppose if I say that this position means distance, okay, distance. So it is possible that a body can be same distance, but still the body can move. Right? Are you understanding this? Suppose for example I see a car, and that car is going like a circle, like this. If car is moving like a circle, same distance, 2 meter, let us say 2 meter, but it is under motion, in a circular motion. The distance is not changing because the radius is 2 meter. Okay, radius is 2 meter, but it is under motion. So the position is not just the distance. Position is not just distance. It is also having a direction. Suppose if I say car is 2 meter this side, now car has moved and it has come 2 meter this side. So direction is also changing, right? Direction is changing. So position is not just the distance. Position is a factor quantity. Position is a factor quantity. Factor quantity means it has direction as well as magnitude. So position itself is a vector quantity. Here itself you note this position is a vector quantity. Vector, it is a vector. So this position vector, if this position vector is changing, then it is under motion. If the position vector is not changing, then it is not in motion or it is at rest. Okay, so this is the main idea. First, position, and all this measurement is done with respect to the observer. Right now we can choose observer as origin. Observer is standing at the origin. So now in a straight line you can take x-axis or any y-axis, also you can take any axis you take, but let us take this as x-axis. So this observer, wherever the observer is standing, this is x is equal to 0. It is called origin. Now if the car or any object is here at some distance from this side, this is the position. So this person will measure the position of this body. So position is a vector quantity. It can have sign plus minus. So in a straight line, note that in a straight line we can indicate position this side as positive and this side as negative. Okay. So in a straight line, if a body is moving in a straight line, we can indicate the position with a plus minus sign. If it is towards the left side 2 meter, it will be minus 2. If it is right side 2 meter, it will be plus 2. Okay. So position is important. It has a magnitude as well as direction. Okay. So in a straight line, we can write the direction with plus minus. Okay. This is the first thing. And a straight line means the body is moving only in a straight line. This line can be any direction, it doesn't matter, but let us fix this line as x-axis. Okay. So the position will be represented by x coordinate. Right side is positive, left side is negative. Okay. So this is called position. Now let us understand that change in position, that is called displacement. Second topic is displacement. Displacement. Displacement is nothing but change in position. Change in position. Change in position is called displacement. Suppose if there is a body which was at this position and then this body started moving, and now this body has come to this another position, a new position. So this was the origin 0. So from here this position was x1 and this new position is x2. New position is x2. So the body has moved from position 1 to position 2, from position x1 to position x2. So what is displacement? So displacement is written as delta x. Remember, delta means, this is called delta, and delta means change. Delta means change. So change in position means final position minus initial position. Change in position means final position, minus initial position. Change in position means final position minus initial position, and final position is x2, initial position is x1. Show x2 minus x1. This is called displacement. Are you understanding this? Okay, fine. So x2 minus x1, that is called displacement. Okay. Now, how to calculate displacement? Let us do some calculation here. Let us say if a body goes, let us say if there is a body and it is at a position of 2 meters, distance is measured in meter, and now let's say this body has moved and this body has come here and this position is 10 meter. So what is the displacement? Find displacement. Find displacement. So this was the position when time was 0 second, and this is the position when time is 2 second. So in 0 second it was here and 2 second it is here. So what is the displacement? Let us calculate that. Displacement, how to calculate? Delta x displacement, final position minus initial position. So this is position 1 initial and this is final. So final position is 10, 10 minus initial position is 2, 10 minus 2, 8 meter. This is called displacement. Okay, very easy. You have to just subtract that final minus initial. When you subtract that, that is called displacement. Okay, done. So this is what it. One more question. Let us take one more question on this. Now you can give the answer. I'll give a question. You try this. Suppose there is a body and it moves from one position to another. Right now it is at a position of x equal to minus 20 meters. and this position is x is equal to plus 20 meters, and this was the time when 0 second, this is the time when 3 second. So find displacement, find delta x, find displacement, give the answer, find displacement. Right, you are correct. So displacement is delta x is final position. So starting is here, this is final. So 20 minus initial position minus 20. So this 20 plus 20, right? It become 20 plus 20, which become 40 meters. Yes, correct. That is 40 meters. Right answer. Okay, so you understood. Next, let us go next. Next is what is velocity? Velocity. No, I think distance also we need to see. Distance. Third thing is distance. Distance. So distance means what? Distance means the length of path. The length of path traveled by a body, by a body. Length of path traveled by a body. Length of path. So length of path is nothing but it is just the measurement of distance. So this is distance is a scalar quantity. It does not have any direction. Distance is scalar quantity. Okay. Now, in general, it can go, body can go any path. Suppose, for example, if a body goes like this, like this, like this, like this, like this, it comes here. So, in that case, distance you have to calculate as, how to calculate distance? Distance you have to calculate the sum of all this length. This length, total length you need to add this. Add this length you need to keep on adding. You can divide it into small length, right? So small length you can write it. So then you need to keep on adding all these small length, and then it will give us the total distance. Okay, so small. I'm just cutting it into small parts. Small parts. We cut it. Okay, then measure. So this length which we have to measure technically and according to maths, how do we measure? We take a very small length which is just like a small straight line. So this is we call as DL. DL is the small length, and then we can add this all small DL, that is called integration. So integration of DL will give us delta L. Delta L is nothing but the change in the length. So total length covered is integration of dl, and suppose if this is a graph y equal to f of x graph, okay, then this, I think you must have some idea about integration and differentiation, right? Some idea you will have. So suppose if I take this small length dl, and this is small angle is dx, and this is small length is dx dy. So the body is traveling along this path. This path may be some path, we do not know. But right now we have to cut a small length on this. A very small length we have cut it. And this small length is just like a small straight line. Although this is not a straight line, but this is so small that it is just like a straight line. You can assume it to be a straight line. So it is like a straight line, and in this triangle, this angle is theta. This angle is theta, and you know that dy by dx is tan theta. I think you know that, right? Dy by dx is called slope. Differentiation, it is called tan theta. So anyway, if you want to calculate this length, what you can do, you can apply trigonometry here. So cos theta, you know what is cos theta. Cos theta is what? Cos theta is base dx by hypotenuse dl. So dl becomes dx divided by cos theta, and it becomes dx secant theta. So dl can be now written as secant theta dx. Secant theta we can write as root under 1 plus tan square theta dx. Now this tan theta is dy by dx. So dl can be written as root under 1 plus dy by dx whole square, because dy by dx is tan theta into dx, and then if you want you can now integrate it to calculate the total length delta L. This is the mathematical technique to find the distance, and this is for general. Okay, if the body is not going in a straight line, in any other direction also it is going, we can calculate, and this is the actual way to calculate distance. But of course this is going to be very difficult because it involves maths. Integration, this formula we should know, right? Integration of root under 1 plus dy by dx whole square, this whole integrating with respect to x. So this is the idea behind calculating the distance. But in a straight line, calculation will be little bit easier when body is going just in a straight line. And also note here the meaning of displacement here. Displacement is nothing but the shortest, this shortest path between initial and final, that is called displacement. This is called displacement, shortest path. Okay, this is called displacement. But more detail about this you will be studying in the next chapter, where you will be studying motion in a 2 dimension, because in 2 dimensions body can go along any path. But here we are focusing only in a straight line. So displacement calculation is very easy, which we have already done, final minus initial. So do not worry about this right now. So distance, how do you calculate in a straight line? Let us understand that. Suppose if a body is going in a straight line, okay, let us say body goes from here to here, from A to B, and then body goes from B to C. It comes here, let us say. Okay, so time, let us say 0 second, it is here. Time 2 second, it is here. Time 5 second, it is here. Okay, so let us write the position also. This position is XA position, this position is XB, and this position is XC. Okay, so how is the body moving? Body is first going from A to B, and then moving from B to C. Note that this is how the motion is happening. This you have to note. A to B body is going, and then B to C body is going. So this is how the motion is happening, because body is turning backward. Body is turning backward. It may not turn backward also, but body is turning backward. So how to calculate displacement is very easy, because final minus initial you have to do, that's all. So final means XC minus XA, that you will do, you will get displacement. But distance, how do you calculate? Distance. To calculate distance, you need to break this motion into A to B and B to C. Okay. So to calculate distance delta L, you have to measure AB plus BC, because it is the length of motion, how much it is moving. So that length we have to measure. So AB will be nothing but magnitude of, you can write AB as magnitude of displacement from A to B. A to B displacement you can take. Similarly, this you can take magnitude of displacement between B to C. Why magnitude? Because the magnitude will give only positive values, because distance cannot be negative. But displacement, because you are calculating displacement, so it can be negative also. So that is why we will put a magnitude to make it positive. So now you can also calculate this as AB. You already know AB is B minus A displacement, so XB minus XA, and take magnitude plus this displacement BC is position of C minus position of B. That's what it is. This is how you will calculate in a straight line. You will calculate distance. Are you clear about this? Yes. So let us take one question. If you're clear, let us take one question. Calculate distance and displacement both. So suppose the body is moving. So time 0, x is equal to minus 2. Then time 2 second, x is equal to 10. Then time 3 second, x is equal to minus 10. Okay, so question is, so note that how the body is moving. Body is first going from here to here, and then it is going here like this. Okay, so you can now find out distance and displacement. Find distance and displacement. Find distance and displacement. Calculate. Any answer? Displacement is minus 8. Okay, let us check that. So final position here and initial position here. Okay, so final minus initial you have to do. So suppose if I write this as ABC. So final is position C is minus 10. So C is minus 10. Final minus initial. Initial is A, which is minus 2. Yes, you are right. Good. So minus 10 plus 2 become minus 8, right? Meters. Then what is distance? What is the answer? Distance. Hmm. Yes. Any answer? 28. Okay, so let us check that. So AB plus BC. AB. So AB magnitude we will calculate. Magnitude is B minus A. So I'll put mod, and here also mod I will put. Mod means magnitude. AB means final position minus initial position. So here is 10 minus position of A minus 2. And then BC. BC means C minus B. C is minus 10 minus B is 10. Right, so let us calculate this. So this will become 10 plus 2, 12 it will become, plus this become, right, 12 only, na, right, and this is minus minus 20, so magnitude is 20, so that become 20, 32, right, 32 it is becoming. Check that. AB, A to B, so 10 minus minus 2, 12 it is, right. Then B to C, BC. So position of C minus B. So minus 10 minus of 10 minus 20, magnitude is 20. So 12 plus 20 is 32. Yes. Any doubt in this? Okay, fine. So you understood this. Okay, so distance, displacement, you are clear. Now let us see what is velocity and what is speed. So velocity. Fourth one. Velocity is the rate of change of position. Rate of change of position. Rate of change of position. So suppose if a body from the origin, this is the position x from origin, then rate of change of position means differentiation dx by dt, that is called rate. Okay, so this definition of velocity is the fundamental definition of instantaneous velocity. This is called instantaneous velocity. Instantaneous velocity means velocity at a given instant of time. So right now some time will be there, time is t. So time will change, velocity can also change. So at a given instant of time, what is the velocity? That is called instantaneous velocity, and this is a straight line motion. So we are defining this along only a straight line dx by dt. Because x can be positive, so it can also be positive. X can be negative, it can be negative. So because the position is a vector quantity, velocity is also a vector quantity. Okay, velocity is a vector quantity. So this is the definition of velocity, which is instantaneous. But there is also another definition called average definition. Average velocity. Average velocity. So average velocity means over a interval of time. So body is moving and body has come here. So suppose this position was x1, x equal to x1, and this position is x is equal to x2, and here time was t equal to t1, here time is t equal to t2, and body has moved in this way. It has moved from first position to second position like this way. So now what is called average velocity? Average, v average is defined as total displacement by total interval of time, delta x by delta t. It is also rate, but this rate of change of position is measured over the interval of time. So that is why it is called average, and this is measured at a given instant of time. It is called instantaneous. Okay. So this is the definition of average velocity, delta x. Of course, delta x you can now write as x2 minus x1, x2 minus x1, and delta t you can write as t2 minus t1. T2 minus T1. Like that we can calculate average and instantaneous. Okay, so similarly we can just take next definition, then we can go for calculation. Next is speed, average and instantaneous. Average speed, and again here also instantaneous speed. Instantaneous speed. So average speed means average. Here I will just write the speed so that it should not get confused. Average speed. Average speed means total distance delta L by the interval of time. This is called average speed. Instantaneous speed I will simply write as a speed. This speed is equal to, or if you want, let's write instantaneous. Instantaneous speed is equal to, this length will be at a given instant. So it is like differentiation dl by dt. So the idea is very clear here. We need to understand that suppose if a body is moving. So if the body has moved over an interval of time, then this is the length which it has moved, delta L, and in this time it has moved to delta t. So the total distance by total time, this is what is called average speed, which we have studied in grade 9 10th. No, whatever formula, speed equal to distance by time, speed equal to distance by time, that is nothing but average speed. Nobody has studied instantaneous. Only in grade 11 you study instantaneous, because differentiation then only you learn. Previously differentiation calculus is not there in grade 8 9. Okay. Of course, nowadays in foundation they are studying that also. Okay, so this is now how do you say instantaneous? Instantaneous means you are taking a very small interval of time. Time interval itself is very small. So in this small interval, the motion that has happened or the displacement that has happened is also very small. So suppose if I say displacement, so displacement I can say dx. Displacement I can say dx, because x means position, so change of position is displacement. But I want dl, I want magnitude. So dl is nothing but the magnitude of dx. This we have to understand, because this is the length and that is the displacement. Of course, it is a very small time. Okay. So this instantaneous speed I can write as magnitude of dx by dt. So I can write this as whole as magnitude of dx by dt. And note what is dx by dt. What is dx by dt? Dx by dt you have studied, which is instantaneous velocity. So instantaneous speed is nothing but the magnitude of velocity. Instantaneous speed is magnitude of instantaneous velocity. Instantaneous velocity. So instantaneous speed is the magnitude of instantaneous velocity. This is the key idea here. Okay, so this is speed, instantaneous speed, velocity, instantaneous velocity. Now here you can note that very important point. Note this point, that if a body is moving, let us say body is moving and it doesn't change direction. So motion in a straight line, the magnitude of distance and displacement will be same. But if the body changes direction, let us say it goes forward and comes backward, then displacement will become smaller. Very simple example to understand that: suppose you go to school and come back home. Okay, so you start from home, you go to school and again come back to home. So your initial and final position is the same. right? So it is going, displacement is going to be 0 because final position initial position same, so displacement is small, 0. But you have covered distance, you have gone very far away to school and come back, so distance is there. So we have to note that distance, which I can take as delta L, is always greater than equal to displacement magnitude. Okay, note magnitude we are comparing because distance is anyway positive, displacement can be positive, negative. So magnitude we have to compare, because you cannot compare a scalar with a vector. Scalar and vector, only vector magnitude should be compared with a scalar. We cannot compare direction, right? So direction cannot be compared because this is a vector quantity, this is a scalar quantity. So magnitude of vector can be compared with scalar. Okay, this is one idea. Another thing is that because of that, if you take average, average means you divide by time. So average speed, that's why average speed is going to be greater than equal to average velocity, that also magnitude again, average velocity magnitude. Okay, so average speed is going to be greater than equal to magnitude of average velocity. But what about instantaneous? Instantaneous, they are equal, that already we have seen that. So instantaneous speed is equal to magnitude of instantaneous velocity, magnitude of instantaneous velocity. So these 3 points question can come in it. Definitely some questions are coming in NCRT also, lot of questions are there based on this. Okay, so this is all about speed and velocity. Then acceleration, let us see the acceleration also. What is acceleration? Acceleration, again acceleration we can define as average acceleration and instantaneous acceleration. Instantaneous acceleration. So what is acceleration? Acceleration is the rate of change of velocity, rate of change of velocity, rate of change of velocity, that is called acceleration. So instantaneous means, let us say very small interval of time you take dt, and during this interval the velocity changes, right? dv is the change of velocity. So acceleration is defined as dv by dt. This is the instantaneous acceleration. But if you take a large interval of delta t, and here the velocity change that has happened is delta v. So here the average acceleration, a average is equal to delta v by delta t. This definition is over an interval of time. Okay, and that is instantaneous. Okay. That's the key idea here, and note that acceleration is also a vector quantity. Acceleration is also vector quantity. So after that, the next thing is jerk, but generally jerk is not also given in NCRT and generally not coming, but still let us note that what is jerk. So further change of acceleration with respect to time, that is called jerk, and jerk can also be average jerk. Average jerk means delta A by delta t, that is average, and instantaneous jerk, that is equal to dA by dt. So jerk means rate of change of acceleration. Jerk means, jerk is the rate of change, rate of change of acceleration, and it can be instantaneous and average, but mostly questions are not coming in this. So we are done, we have understood the definition of all these things. And tell me, do you know the differentiation, integration or not? You have idea? Hmm. Okay, so basic idea is needed for that differentiation. So right now I will not go, maybe next class we will go in more detail about that. Okay, So right now you can work questions on this. Okay, so I will give you, but basic formulas I think you may be knowing. I will tell you some basic formula for differentiation, because differentiation will be used a lot here, kinematics. So differentiation x to the power n with respect to x. This formula is n time x power n minus 1. This formula is the most important formula. Okay, so differentiation formula, we should note this. Suppose, for example, you have to differentiate x power 3 with respect to x. So this is called 3x power 3 minus 1. So this becomes 3x square. So what you need to do is the original power you have to keep here, right? This original power you have to keep, and you have to decrease one power in this variable. That's how we can do that. Can you hear me? Okay, so this formula we should note that we will keep original power multiply with power we will decrease. So for example, x cube differentiation with x is 3 comes out, x power 3 minus 1. So that means 3x square. Like this we can use, and it has got lot of application. Let us see its application here. What is the application in kinematics? So for example, if a body is moving and let us say its position is changing with time as t square, and they ask find its velocity, at time 2 seconds. So velocity means instantaneous velocity, which is dx by dt. So now you are going to do the differentiation. So t square with respect to t. So the power of 2 will come out, and t power 2 minus 1, that will become 2t. So this velocity is 2t. Now you substitute time. So 2 into time is 2. So 2 into 2 will become 4 meter per second. This is the velocity at 2 seconds. Okay. So this is the application of, the application of differentiation. So lot of applications are going to come. Let us solve one question. You try this. I'll give this question. Suppose a body is moving like this, and x is changing as t cube. Find its velocity. Find its velocity at t is equal to 10 seconds. Find out. 300. Okay, let us check that. So velocity is equal to dx by dt, t cube differentiation with respect to t. So velocity become 3t square. Okay. Now 10 seconds. So 3 into 10 square. 300. Yes, correct. That's the right answer. 300 meter per second. Clear? So I hope you understood this. Everything you understood today class, right? Okay. So we will plan the next class accordingly. Okay, timing. So you are right now available anytime because you are in home, right? Okay, fine. So, so I will tell you the timing tomorrow if it's possible. I will tell. Okay, so maybe daytime or afternoon time sometime we can take. Okay, so also I will share you some links of the NCRT solutions I have posted in the YouTube channel, and very detailed solutions I have given, including the NCRT exercise, including the this exemplar, NCRT exemplar. Please go through that solution, and everything is covered in this chapter. Kinematics. Other also will I am planning to make it, but timing is constraint. But I will definitely make it. Okay, so you go through that, and integration differentiation videos are also there from the very beginning, particularly for NEET student. Those who don't have the maths basic, I have made videos on basic maths, okay, which includes all the all the formulas, all the things. So you can watch them and you can make the list of all the formulas. It will be good. And once you go through it, after that, if you want, you can tell me test. I will take your online test. Okay, online you have to register on my app. I will send you the link also, so you can download that app. In that app you can register for that. Online there are free tests, that's not a problem. But you will be joining the NEEV batch, because right now in grade 11 topics you are doing, right? So for that NEEV batch you can join. Once you can cover up that, then you can go for the other batch, grade 12. After that we will see. First NEEV batch topics, whatever you have grade 11 topics, you can tell me, those topics will cover. Fine. Okay. Right, then today we'll wind up, then we'll see next class. Okay, bye bye.